Okay, so let's do some limits at infinity. And what makes them different than our other ones is instead of going towards a particular number, we're actually going towards infinity or negative infinity when we're talking about these ones. So what we're doing here is we're imagining what happens to this function when x gets really, really, really huge in the negative or positive direction. Okay? And actually, you've done this activity before, even though you haven't thought about it. So if you're thinking about something like a polynomial function, you've done this when you've thought about end behavior, right? Isn't end behavior of a polynomial function asking you what happens at the end of the function, at the very end? So, like this is a fourth degree polynomial that has a negative in front. So it's probably something that looks like this. So what are they asking you when they ask about end behavior? They're asking what happens on the very ends of this function as we move out of here where x is really huge, right? Isn't that basically the same question? So when you see a limit of something like a polynomial like this, what they're really asking for is kind of what's the end behavior? And they're asking for only the end behavior on this side because they want to know when x is going towards positive infinity. So one way you could do it is actually just imagine what the picture looks like. The other way you could do it is imagine it like kind of numerically and stick in, if you could like imagine putting in infinity here, right? Well, again, what you want to do is usually what we do is since this guy is so much huger than all of these guys, we kind of don't worry about them too much, right? This is that idea that we've talked about over and over again, where we kind of say, well, this guy is going to get so big that over time, these numbers are going to become meaningless. It's like being an $8 trillion heir, right? You have $8 trillion in the bank, and then someone asks you for $2. Well, who cares, right? $2 doesn't mean anything to you. Or someone, you see $2 in the street, you're not going to bother to pick it up. But the same would be true if you have $8 trillion or whatever. And then over here, this is actually only like $100,000 or something. To you and me, $100,000 seems gigantic, but to a trillionaire, it doesn't mean that much. So these numbers start to become meaningless, and really this is what we have to think about. And so what's happening here is it's going to be a negative infinity, right? Because this will be infinity to the fourth. So imagine the biggest number, that is possible to the fourth power, and then it's going to be negative. So all of these guys don't matter, right? Because this is to the fourth power. So you're always going to be an infinity times bigger than whatever this is. Do you know what I mean? So again, you can think about it graphically, or you can think about it sort of algebraically, I guess. In any case, this is going to be going towards negative infinity. Okay, so for polynomials or those functions that you kind of know what they look like, you can think about their end behaviors. Now, the next one we're going to look at is a rational function here. And again, you've done this activity with rational functions where you've thought about what happens when x gets really, really huge. And in this case, it's kind of like the activity that you've done with your horizontal asymptotes, because again, what is a horizontal asymptote? It asks, what's the y value, or in other words, what's the function value, what's the value of this fraction, when x gets really big or really small? And this is asking that same question. It's just that it's only asking on one side. It's only asking when it gets really big. Okay, so you already know how to do this. It's like finding a horizontal asymptote. So how do I go about doing such a thing? Well, I think about this guy. And again, when we're looking at this fraction, what's going to happen is these little guys in the back sort of become insignificant, right? It's like having a bunch of money and then, just a little bit of money added or subtracted. If you had $1 billion in the bank and then, you took out $5, nobody would say, oh, he's not a billionaire anymore. They'd be like, he has $1 billion in the bank. Or if you had $1 billion and you deposited $5, nobody would be like, oh, he has $1,005,000,000 in the bank, right? These numbers don't matter. They're insignificant. Okay? They become insignificant as x gets huge. And we're only talking about when x is at infinity. So, x is humongous. So $2 or 2 times whatever that number is isn't going to matter. Okay, so I'm really only going to be thinking about this guy. So if I think about it, right, it's going to be, so this is the activity I'm doing in my brain, even if I'm not writing it out. This is kind of what I'm thinking about, right? So what's going to happen is this will cancel and this will cancel. So it's like having 1 over 2 times infinity. Well, what size is that fraction? It's super, super small, right? Almost zero. And in fact, the bigger you put x, the bigger you make x, the closer this gets to zero. So what is the limit as x approaches infinity of this guy? It's going to be zero. Just like our horizontal asymptote is y is equal to zero, right? And some of you learned it as by the degree. So if the degree is bigger on the bottom than on the top, then you know that that fraction is going to get close to zero. Now, the only thing that is you have to check on these guys, because it is different to say the limit as x approaches negative infinity. Not for this particular one, it's going to come out the same, but you do want to make sure that you're thinking about the signs, because again, for this one, we're going to ignore these guys. Well, not that too, but and you're going to be thinking about, negative infinity over 2 times infinity, negative infinity squared. But again, this is going to be, 1 over 2 times negative infinity squared. Even though this is negative, it's still a very, very small magnitude. It's getting close to zero, but it's actually approaching from underneath instead. So this one is still zero. But you got to be thinking about those negatives, especially when these ones that are going to infinity. That's when it's more important, because to say going towards negative infinity is different than infinity. Okay? So that's why it was important to take into consideration. All right, let's just look at this one quickly. So this one, again, what do we want to do? We want to think about it when x is really, really small this time. But again, I'm only going to really be thinking about, I'm going to ignore this guy. I'm only going to be thinking about these things in front. So it's really this over negative infinity squared. So what kind of value is that going to be? Well, it's going to be, again, going towards zero, right? It's almost zero, because you have a really, really big number on the bottom. Okay? And we'll skip this one for a second, but let's take a look at this one instead. Let's take a look at something that looks like this one. So again, what I want to do, this one is negative infinity, so I'm going to be thinking about negative infinity. So again, I ignore everybody that's not the first terms, because they're going to be small in comparison. So I'm just going to pretend they're not even there. I'm going to ignore them, right? Just like we do in society with people that, don't seem to be significant, right? So this is what happens. We just pretend they're not there for a little while. Okay, so what we're going to do is we're going to take these first two, and we're going to say 2 times negative infinity over negative infinity. And there they are. So what's happening here? These cancel. Negative infinity cancels. And it gives us a 2. Okay? The same would actually be true if it was positive infinity, because the positive infinities would cancel. Is everyone with me? Not that I think anybody's insignificant. You know that. That was meant to be political humor. It wasn't very funny, though, I guess. So, all right, here's the last one. You ready? I'm better at math than I am at humor. Here's our last one. Okay, here he is. We're going to try to put infinity into here. And this is just like our rational one, except for this one doesn't feel the same because we have that radical there. So you know what I like to do? I like to do that, eliminating the things that don't matter as much in here. So uncluttering this one by getting rid of all of things that are small and insignificant in terms of infinity. So he's going to be insignificant in terms of infinity. Right? That 1 isn't going to add or subtract that much value from me at any point. So I'm just going to not worry about adding that amount in. So now we're left with this. So if I kind of imagine that that doesn't exist, then what do I really have? I have this, don't I? And this thing is kind of like the same thing as, do you see it? So if I do the, get rid of the insignificant stuff first, and then go ahead and think about it this way, just think about my leading terms, then it's kind of like having this. Well, it doesn't matter actually what x is, does it? Whether it's big or small, this is going to go towards, 1. So my limit will be 1. Okay? Do you see it? I hope so. Okay, so there you have it. Beautiful limits at infinity. Take a try at those. I think you'll be successful.